In this video we'll go through a hypothetical but not hard to imagine real problem of user search that takes certain amount of time to complete. We'll implement the solution using traditional Spring MVC servlet framework and server-side rendering and look at what problems we might face. Then we'll switch to Reactive paradigm and Spring WebFlux framework for our API and Angular web framework for our user interface to try to solve the same problem. After we fail in our initial attempt, we'll see what it takes to implement fully reactive non-blocking asynchronous application. Our goal is to work on the same problem using different paradigms. We want to implement user search in hypothetical scenario. When we press one character, we want user search to return one item with that character. When we search for two characters, we want the results to be two items separated by half a second apart. When we search for three characters, the result should be three items, each separated by half a second apart. The goal is for search to be obvious and to introduce delay to simulate slow network conditions. Let's see how we'd implement this using classical servlet API supported by Spring Web MVC framework. To generate the project, we'll go to Spring Initializer site at start.spring.io, and I've already pre-populated the meta fields. We'll add web dependency, timelive dependency, and Lombok dependency. We'll generate our project and open it in our IDE. Once we've opened the application in our IDE, let's start implementing the functionality we'll need. First, we'll create a record that will represent our search result. And it will have one field, let's call it result. Next, we'll need to implement our search service that will return a list of search results based on the query user passes. We'll annotate it with the @service and Lombok @value annotation to generate constructors, getters, and setters for us. And we'll have a search method that will take in user query and return a list of search results. We'll return integer stream, let's say closed range going from 1 to query length, and we'll need to map it to object to return, for each integer we'll return new search result, let's say string format. We'll say %i for %s, and we'll give in the integer and the original query. And we'll collect it to a list. And we want to introduce a delay between each item, so we'll say for each item introduce thread sleep of 500 milliseconds. And that should be enough for our service. Next, we'll need to create our search controller that will use our search service. We'll annotate it with @controller, Lombok value, and we'll say that request mapping goes to our root page, so /. We'll create a get mapping that will display our search form, so show search form, and it will return search index, search HTML, sorry. We'll need to create it, so we'll go to our resources templates directory and create HTML, search HTML. And I've already prepared some HTML that will have input for our search and a place where we can display results. Let's work on our HTML. We'll need to create an action for our form. First, we'll say that the method is post, and the action will be post to /. We'll create it in our controller once we finish with the HTML. So action will go to /, post to /. For our input, we'll say that the ID is Q for query, name as well, and results we'll receive in results variable, so we'll say that for each R, which is a result, in results. We'll display it in a header with data.th text. And our search result has result field, so we'll say R result. Let's go back to our search controller and implement post mapping needed for our form to work. We'll call it search, and we'll need request param, we'll call it Q in our input. We'll also need redirect attributes because we'll post and redirect back to our home, our slash page. On our attributes, we'll add flash attributes as a result of search, so we've called it results. And we forgot to import our search service. So search service to have it accessible in our controller. And we'll use it in our when we create our search results. So we'll search on the user based on user query, and once that's done, we'll return redirect back to the home page. And that should be enough for our search form to work. We'll start our application and hit localhost 8080 and test it out. Let's say ABC. And we see 3 results. They were separated by half a second apart. So if we say, let's say something for 6 letters, we should see results after 3 seconds. Currently, users have to enter their search and press enter to submit the form. We'd like to improve user experience and return search results on their every key press. We'll do that by updating only search results with server-generated HTML every time search input changes. Let's go back to our application and implement the functionality. So we'll need another post mapping. We'll call it search. And let's say we'll call the method partial search. We'll receive request param the same as above, called Q, and we'll return, well, let's see what we need to return. In our HTML, we want to return this part of the HTML that's responsible for displaying a result. We've given it ID of search results card, and we also need to populate results attributes so the results will be correctly displayed. So what we need to return in our search HTML only the ID of search results card, and we need to add a model to our method signature and populate it with search results. So results. And the same as above, we'll call our search service and search on what user gives us. Let's use our partial search in our HTML. So we'll create a script tag, and in there we'll create a function. Let's call it replace results. What we'll need to do in the function is first get a hold of the value of the current value of our input. So we'll do that. Let's call the input query. We'll do that by using jquery, and we have the ID of Q, so we'll say Q and just get the value of the input. And what we'll do is we'll post to our search endpoint. We'll give the value of Q will be value of query, that's the current value in the input. And for our success function, once we receive the data, which is the partial HTML, we'll just replace this whole HTML with the newly generated HTML. So we'll say that the ID of search result card, new HTML, is the data we received back from the function call. And the last thing we need to do is every time the input changes, we need to call the function. So we can do that by using data.th attribute. we'll say onKeyUp is equal to literal of replace results, which we'll call the function. Let's restart our app and go to our search page. And let's open a network tab to see what calls are getting triggered. And let's input a search of ABCD and then back to C. We notice that our search results are incorrect. We have 3 characters in our input and we have 4 items results. If we inspect network calls, we'll see that a distinct search is being performed for each of our key presses. But since 4 characters, ABCD, search is half a second slower, results returned for it overwrote the 3 character search results. We have a race condition. We are also hammering our server with unnecessary calls. We should make our partial update smarter. For starters, we can at least fix correctness of our search results by tracking which search was performed last and only update results in that case. So we'll say that we have a last search variable. It will be equal to our query, and only if the last search is equals to what we queried for, we'll update the search results. That should at least fix our correctness. So if we go back, refresh, and perform the same query again, we at least get correct results. But we are still hammering our server with unnecessary calls. We'll stop our implementation here. Couple of lines of JavaScript were fine, but with more complex logic, where we would need to cancel HTTP calls, it would become harder and harder to maintain. It seems like we are swimming against the tide. We'll try a different reactive approach, and we'll discuss what reactive streams are next. Reactive streams is an initiative to provide standards for asynchronous stream processing with non-blocking backpressure, and is aimed at JVM and JavaScript runtime environments as well as network protocols. It was created to address the problem of programming model built around reacting to change, where on one side you have publishers of data whose volume is not predetermined, and on the other side you have consumers interested in resources. But the most prominent issue is that resource consumption needs to be controlled such that a fast data source does not overwhelm the destination. In other words, backpressure is an integral part of the model, through which publisher and subscriber mediate, and which purpose is to let subscriber control how quickly or how slowly the publisher produces data. Reactive Streams initiative scope was to provide a minimal set of interfaces, methods, and protocols that will describe the necessary operations, and they are publisher, subscriber, and they communicate via subscription, and another interface that denotes that someone is both publisher and subscriber, called processor. It may seem pointless to have a processor interface, but in practice it proves to be very useful, and it's good to name things to facilitate easier communication. Interfaces are defined both for Java and JavaScript, or should I say TypeScript, and are pretty much identical. Publisher has subscribe method which enables subscription. Subscriber has onNext, onError, and onComplete methods to be notified when an item is available, error occurred, or when publisher is finished producing data. Via subscription, request and cancel methods, subscriber can control backpressure or cancel its subscription. And we already discussed that processor is just a subscriber and a publisher at the same time. Spring MVC framework, which we were using so far, was built for blocking servlet API and servlet containers, and blocking contracts, such as filter. In Spring ecosystem there's another web framework to support reactive, non-blocking web stack, Spring WebFlux. Reactor is the reactive library of choice for Spring WebFlux and was developed in close collaboration with Spring, but framework is interoperable with other reactive app implementations like RxJava and even with Kotlin coroutines. Spring MVC and Spring WebFlux support annotated controllers, but the key difference is in concurrency models and default assumptions for blocking and threads. In Spring MVC and servlet applications in general, it is assumed that application can block. For this reason, servlet containers use a large thread pool to absorb potential blocking during request handling. You can akin servlet architecture to highway toll collection, where every toll booth represents processing thread. In Spring WebFlux and non-blocking servers in general, it is assumed that applications do not block. Therefore, non-blocking servers use a small fixed-size thread pool, event loop workers, to handle requests. Threading model looks more like a queue for a line in a bank, where you get served as soon as you get on the front of the line and one of the counters gets freed. Angular is a web application framework optimized for complex single-page applications for enterprises. It's built on TypeScript, which brings support for types to JavaScript. All Angular core components embrace reactive asynchronous programming paradigm and implemented using reactive extensions for JavaScript library, or short RxJS. Key term RxJS uses for publisher and subscriber roles are observable and observer. We'll use Spring WebFlux to provide search API and Angular to provide user interface for search results. Fear not if you didn't use Angular before. I'll walk you through key concepts as we go along. One important point about Reactive Stack is it tries to be all or nothing proposition. You have to use reactive types from the source you get the data from, such as database, all the way through your app, till the moment you hand off data off to your clients for consumption. While no SQL databases like MongoDB and Cassandra are built for data streams, so the transition is straightforward. Relational databases traditionally have blocking API, like JPA. While you do have publish on operators to switch blocking calls processing to a different thread pool, if you do that, you would not be making the most of non-blocking web stack. To address relational database connectivity blocking access issue, new Reactive Relational Database Connectivity R2DBC spec was created. It's effectively a reactive alternative to JDBC, enabling non-blocking persistence against conventional relational databases such as Oracle, Postgres or MySQL. Because it's built on reactive streams, it's quite different from JDBC and its separate specification, unrelated to Java Standard Edition. Spring Data R2DBC is a sub-project of Spring Data that offers repository support for R2DBC. So to conclude, if we use Reactive Stack, we need to use reactive types as input and output, and to transform data, we need to use reactive operators. Reactor, reactive library, which we'll use for Spring WebFlux, provides reactive types in a form of mono and flux APIs, which are types to work on data sequences of 0 to 1 and 0 to n elements. Let's again go to Spring Initializer to create a project for Spring WebFlux API. So we'll use Spring Reactive Web Support and Lombok again. And that's all we need. We'll generate the project and open it in our IDE. We'll need to create similar functionality as in our Spring MVC example. So first let's create search result record that will have an attribute of result. Next we'll need to create search service. We'll annotate it with a service and it will have a search method, but this time instead of returning a list of search result, we need to return reactive type, flux. Flux of search result. We'll also call it search. And we'll import the flux. And we'll return, so flux, range, starting from 1 to, we'll need to pass in the query here. Starting from 1 to query length. We'll map our integers to search result objects. Let's do string format as in previous example, %d %s jquery, and then we'll use delay elements operator, that's reactive operator, to delay them for the duration of 500 milliseconds. And that's it for our search service. Next, we'll need to create our search API controller. We'll annotate it with REST controller and Lombok value. We'll import our search service and we'll create a get mapping to /API/search. We'll return a flux of search results. We'll also call our method search. And we'll need to receive request param, we'll call it queue. We'll just return what our search service gives us, so we'll search on the queue. And we plan to use our search API controller from an Angular app which runs on different port, and in order to enable that we'll mark our controller with cross origin. And that should be enough for the implementation of the API controller. If we start our app and try to hit our search API with, let's say, ABCDE, we see we get 5 results separated by half a second apart. If we look at our search service implementation, we'll notice that the Flux operators and usage looks a lot like Java Streams API. So what's the difference? Java Streams API can only be used once and is pool-based, meaning data consumer will decide when they will get the data from the producer. They will request it and synchronously consume it, after which the stream is closed. Reactive streams are push-based, meaning data producer decides when the subscriber gets the data and is asynchronous. Another important thing to consider is that this Flux definition is not executing anything. It's just reactive pipeline definition. You can think about it like a function definition. So what is in reactive terms equivalent to calling a function? It's subscribing to a stream. That's what kicks it off. We haven't called subscribe anywhere in our code, but we still got results when we hit our API. So when did subscribe happen? It turns out that Spring WebFlux framework subscribes for us automatically as soon as we have a client for our API. And to illustrate that, we'll add some log statements. So we'll add a log4j annotation and we'll put an info as soon as our query starts. So we'll say search start and we'll input a query. And then in our pipeline we'll also add a log. If we restart our app, we'll hit our API again and we'll have a look at the logs. So we'll hit our API again, it will run, and if we expand our logs we'll see that there's onSubscribe happening automatically, Flux is taking care of that, and also onComplete is happening automatically, as well as onNext methods. Let's create our Angular user interface next. In order to create and develop Angular applications, you'll need to have Node.js installed. It's a cross-platform JavaScript runtime environment. Once you have Node installed, you should be able to see its version. Node will also install Node Package Manager, NPM, which is equivalent of Maven in Java land. It will enable us to download different dependencies for our JavaScript project. One of the dependencies we'll need when working with Angular projects is Angular CLI, command line interface. And we can run npm install -g for global at Angular CLI command to have that installed. And I've already done that. Once you install Angular CLI, you'll have ng command available. And you can make sure that everything is okay by running ng version. It should get you Node version as well as Angular CLI version. We are now set to create our Angular project, which we can do by running ng new, and we'll call our project Angular Frontend. We don't need routing because we'll only have a single page. And I plan to use ngzoro library, so we don't look at the plain HTML. They work with less by default, so I'll pick less for our style sheet format. And this will take a while, so I'll get back when application gets created. Our application got created, so we'll cd into it. And now we can start it by using command ngserve. This should start our app at localhost 42,000. It might take a while for the first time. And if we go to our browser and hit localhost 42,000, we have our app running. As I've announced, I'll use ngzoro library, and you install it by using ng-add ngzoro nd. So we'll go to our command prompt, stop our application, run the add command, and we'll just wait till we get the prompts. Yes, we would like to proceed. It asks us whether we like dynamic icon loading. No, we don't need custom theme. We'll use English and we'll use blank template for our project. We can run ngserve again, and it's available as just ngs to start our Angular app again, and we'll keep it running in the background while we develop. Files that we change will automatically be transferred and reflected in our user interface, so it's a nice way to develop. If we go back to our application again, there we see the app is refreshed. Instead of the starter page, we see ngzoro, blank template. I've opened our app in Visual Studio Code. By its philosophy, Angular is similar to Spring Boot framework. It comes with batteries included, so with everything Angular team considers you might need for single-page app development. What does single-page app mean? It means that framework dynamically renders user interface components without refreshing the page. If we look at our index.html, it only has app root tag, which is how the whole application mounts. If we have a look at app component TypeScript TS file, we'll notice that the app root selector is there. Angular is a component-based library, and it's intended to nest components in other components to create rich user experiences and to keep UI responsibilities separated. Add component is TypeScript decorator, which is equivalent to Java annotation and is a way to add metadata to a type. Angular tries to separate component logging from its HTML and CSS, so that's why we have template and style URLs and separate HTML and CSS files for our component. We also have a spec file, which is a testing file, because by default you are expected to test. App module TS is module definition file, where you define dependencies for your project, and exports, which is useful in case of larger apps where you want to split functionality in different modules. Let's start implementing our functionality. I'll use ngzoro component library to modify HTML and CSS for our components, so we don't just look at the plain HTML. The way you use ngzoro library is you find a component you like, you copy the import, and you paste it in your app module TS file, and also define it in your imports. And I've done that for the components I need. I've added it to our app component HTML and added some CSS for our application. If we go to our application, we'll see that now we have an input and a placeholder for our search results. To make an API call to our backend, we'll need to use Angular's HTTP client module. If we go to our app module TS file, we'll see that it's already imported for us. Angular HTTP client is reactive, meaning it does not actually make an HTTP call, but rather provides a reactive type observable that we need to subscribe to at time and place in our application when we need the backend data. We'll first create type to mirror our backend search result and then a service to make an HTTP call. A lot of things we need in our Angular app we'll create with its excellent CLI we've already used to create the app in the first place. So let's first create an interface that will mimic our search result. So we'll say ngGenerate, G short, interface. We'll also call it search result, as in our backend. Once that's created, we'll add a property result that will be of type string. And types go after the property name in TypeScript, just like in Kotlin or in Scala. Next we need to create our search service. So we'll say ng for generate, s for service, and we'll just call it search. And if you want to check what the command output would be without actually running it, you can do dry run. This is one of the features of Angular CLI. And in this case it says it will create search service and test for search service. So we don't need tests for now. So we'll say skip tests. And in this case we see that it would create only search service. So that's fine, and we can remove the dry run and create the actual service. If we open our search service, we'll see that it has add injectable decorator with metadata provided in root. That's equivalent to Spring stereotype annotations like add service. Angular also has dependency injection features, and this will create a singleton instance for our service that we can inject and use somewhere else in our application. In our case, we need to make an HTTP call, so we'll also use dependency injection features to inject HTTP client in our service. And then we can create a function for our search. We'll pass in the query, which will be string, and we'll return an HTTP call. So we'll say this HTTP get, and the URL was localhost 8080 API search, and we'll use the backtick so we can interpolate our variable. Now this will return an observable of search result array, and we also have to make it typed in our get definition. So we'll say that this is a search result array. To use our search service, we'll need to import it in our app component. So we'll say constructor private search service is our search service. And we don't need a title. Before we use our service, we have to hook up our form and our input. Angular has two types of forms, template-driven form and reactive. Template-driven form rely on directives in HTML template to manipulate underlying objects and are good for simple static forms. Reactive forms provide explicit access to underlying form object model and are based on reactive paradigm. They also provide a way to expose input value changes as an observable we can subscribe to. We are discussing reactive stack, so we'll use reactive forms module. First we'll need to go to our app module, and we'll need to import reactive forms module because it's not imported by default. We'll add it to our imports as well as define it in our module. And we'll go to our app component TS, and here we'll define the new form. Let's say search form, which will be a new form group. And in our form group we'll have one input, we'll call it Q, and this will be a new form control. Default value will be empty string. Now we need to hook our search form in our HTML. We'll find where our form HTML element is, and we'll say that our form group is our search form, and our input is form control name, and the name is Q. And if we go back to our app component, we'll implement lifecycle method on init, in which we can subscribe to our input just to make sure that everything is hooked up correctly. So we'll say that search form we'll get the control Q, and it has a value changes observable that we can subscribe to. For now, we'll just say that the data we receive when the value changes will output to our console to make sure everything is hooked up correctly. So if we save and go back to our HTML, if we open our developer tools console tab, if we press, we see that the value we input in our Q input are reflected in the console. So the form is hooked up correctly. Danger. What I'm about to show you is not idiomatic way to use a reactive stack. But when you first come to Angular, you're probably inclined to use it this way. Okay, let's first show a non-idiomatic way. We can say that each time our input value changes, we'll just call our search service and issue an HTTP call with the data from our input. We'll subscribe to our search service, and the result we get back we'd like to assign to our local variable. So we'll create local variable, call it result. It will be a search result array, and it will be an empty array for starters. And then the result we get from our HTTP call we'll assign to our local variable. Data can be string or null, so we'll just say data or empty string. And then we'll go to our app component HTML, and in the part where we display results, we can loop over our array by using ng4, and we'll say that R is a result of our result array, and content will display by using double curly brackets. Our search result has result property, so we'll just display it in the card. And we can delete other dummy cards. And we forgot another curly brace here. If we go back to our application and open a network tab, delete previous requests, and type in A, indeed we see we issue a search query to our API. But we still have the same issue as before. If we type ABCD and delete D quickly, we'll get race conditions and we'll have a wrong result displayed. We'll fix this shortly, but let's first discuss what's wrong with our implementation. We have subscription within subscription, and we also created local state. We also created memory leak because subscription to our search service call will not be automatically unsubscribed when our component is destroyed. So this begs the question, what is the idiomatic way? We do not want to explicitly subscribe to our reactive streams in our code. This creates local state and forces us to manually manage subscriptions. Instead, we want to work with observables all the way through to our application frontier. In case of our backend, it's an API call. In case of our Angular app, it's HTML user interface. We saw Spring WebFlux manage a subscription automatically, and Angular can also do similar thing by using async pipe in our HTML, which will automatically subscribe to stream, consume values, and unsubscribe. What if we have two observables, as in our case? We have to use rich set of observable operators to transform, filter, flatten, and combine observables if need be, and the goal is to produce single observable we can pipe to async pipe in our HTML. How do we start implementing change in our case? We know we don't want local state result, instead we want observable of result. So our variable will be observable of search result array, and the naming convention for observables is the trailing $sign. We know we can't have subscriptions in our code, so we'll need to somehow transform our value changes observable from our input to the observable of search result array that we'll get from HTTP calls. To compose observable operators and produce a new observable, we'll need to use pipe rxjs method. And the question is, which operator will we use? Well, there's a switch map operator that maps each value from source observable, in our case this will be form input, to an inner observable, In our case, this will be an HTTP call, subscribes to it, and then starts emitting values. The cool thing about switch map is that each time source observable is changed, in our case HTML input, previous HTTP call will be cancelled and only most recent will be in effect. Let's use this in our code. So we'll say that this result observable will get from transforming the value changes observable. And we'll need to pipe it first, as we discussed, and then use switch map operator. And we'll transform input from our HTML to an HTTP call from our service. So we'll say this search service search, and we'll search on that input. And the last thing we need to do is in our app component HTML, instead of displaying result that we don't have anymore, we'll just display our results observable pipe into Angular async pipe. Having done that, let's go back to our application, clear the logs, and let's go back to our Spring WebFlux application and also clear the logs. And we'll go with ABCD and back to C search. And we see that a lot of requests have been cancelled. Only the last one went through, which is ABC, and we got the correct results in our HTML form. If we go back to our WebFlux, we'll see that we have a lot of cancels. Only the last search, ABC, went through and completed. By using the proper switch map operator, we've been able to solve a couple of issues at once. Let's go back to our Angular application and try to improve our reactive pipeline. First, we'll trim the input. And then we'll filter out blank strings. So we'll say that we need to filter, and we'll accept only inputs that are different than blank strings. And next, if the user types really fast, we don't want to hammer our server with HTTP requests and then cancel them. So we want to wait a certain amount of time. To do that, we can use the bounce time operator, and we'll say we'll wait for 300 milliseconds before performing HTTP requests. And if the user types in A, B, C, D and then back to C, we don't want to perform 2 requests. We want to perform only 1. So we can say distinct until changed. If we now try to perform A, B, C, D and back to C search in our application, we see that only 1 request went through, the correct one. And we've got the correct results. And we've accomplished all of this just by using the appropriate reactive strings operators. Pretty sweet. By now you can see that using reactive paradigm is a bit like learning a new foreign language. You have to learn the vocabulary, which is a store of words, lexicon, in our case operators, but you also have to learn semantics, skill that refers to the ability to understand words and the ability to use them appropriately. There is a big difference in saying this is a sick dog and this dog is sick. Although they use the same vocabulary, semantics of one represents medical problems and the other coolness factor. We still have problems with our search. If we type in lots of characters, we'll notice that we have our old search result present and we only display new search result when the whole JSON arrives. We are not receiving real-time updates. We'll work on the second issue in a bit, but the first one we can fix by piping our HTTP call to an operator that will make it start with an empty array. Start with operator. And if we go back to our application and make a search for ABC, and then type in more characters, we'll see that our previous search result is cleared, and the result page is populated with a new search result. We already saw that when we hit our search service, Angular waits for the whole JSON to arrive before displaying it in our results page. We'd like to process real-time updates. We have 2 techniques available for pushing real-time data on the web. Pull, where a client raises a request to get the latest version of the data, which is equivalent to child asking, "Are we there yet?" Push, where server pushes updates to the client. WebSockets is bidirectional push communication protocol where client and server can exchange messages. Server sent events is unidirectional technique where client requests a resource and then from that point on server pushes updates. For our search use case we'll go with the server sent events. Our server needs to produce text event stream messages and our client needs to accept them. In JavaScript there's event source API we need to use to accomplish that. For our Spring backend API you might think that we'll need to say in our API controller that it produces text event stream. But luckily this is not the case. Spring handles that automatically for us, so I'll just return the controller as it was. And let me demonstrate. If we hit our API normally, we'll get JSON as a result. And if we use an accept header of text event stream, we'll get server sent events from the same API. That's pretty nice. Notice that when we hit our API normally, we get the whole JSON as a result. But with server sent events, we get data packages with singular result as they are produced. I've changed our app component HTML so that it displays blocking search result and server sent event search result side by side. Currently they display the same thing. So if you go to our application and type some letters, we'll get the same behavior. I've just changed the colors of our server sent event search result. Let's go to our search service in our Angular app and we'll create another function that will have the same signature as our search function. We'll call it SSE for server sent events. We'll also have a query and we'll also return an observable of search result array. And we'll need to use event source JavaScript API. So we'll say event source is new event source for our same query as above, for our same API call. We saw that server sent events return singular search result. And we want to have a function that returns observable of search result array. So we'll create a temporary array where we'll push the values we receive. Next we need to create and return our observable. So we'll say new observable for a given observer will be, we need to use our event source callback functions on message and on error to determine what we'll do with our observer. So we'll say on message for a given event, we need to get a hold of the event data, which is our search result. We'll JSON parse it and we'll push it to our results array. And then we'll emit the results array to our observer. So we'll say observer next of the results array. And we also need to implement on error callback of our event source, and we'll just forward the error. So for a given error, we'll just say observer error is the error we receive. The question is, when will we notify our observer that the stream is complete? And in order to do that, we'll modify our onError handler. So we can ask if our event source ready state is 0. That means that the server closed the connection. So remote server closed the connection. In this case, we can close our event source for 1, and we can emit to our observer that our stream is complete. And we'll do the error handling we've done in the else block. The code that we wrote so far wouldn't update the user interface. How does Angular keep user interface updated and in sync? It uses Zone.js library to track execution context that persist across async tasks. And that's how it knows when to trigger ticks that will update user interface componentry. We need to tell Angular that our code also needs to trigger user interface updates, and we do that by using provided ngZone service and executing the code that may update the interface in its run method. So let's do that. First we'll inject the ngZone service that's provided by Angular, and each call to our observer will run in its execution context. So we'll say zone run, and we need to provide an arrow function, so that's lambda in Java terms. So we'll just run the code for our observer in there. And we'll do the similar thing for the complete and for the error callbacks. For our SSE method implementation, we can now use it in our app component. We'll have another result observable, we'll call it SSE result this time. And the code it needs to run is pretty much the same as results observable. The only difference is that SSE will be called SSE method instead of search method. And maybe we can extract commonalities. So we'll create another temporary input observable, let's say, and it will be the value changes observable piped through these operators. And then instead of performing HTTP calls on the value changes observable, we'll perform switch map on the input observable. And similarly for our SSE results, we just need to, instead of calling search method, we'll need to call SSE method. And in our HTML, instead of looping through results observable in our second example, we'll loop through SSE results. If we now go back to our application and perform search, we'll see that SSE search results provides real-time updates. Nice. Another thing we can do in our app component TS is, because we are only working with observables and we don't have state, we can change detection. The Angular defaultly uses from default to on push, which will reduce the amounts of ticks Angular needs to trigger user interface changes. To conclude, blocking and imperative code is not evil, and reactive programming is not your savior. Like anything else in development, we saw that reactive programming might be perfect fit in some use cases and ill-fitted in others. We need full-stack reactive if we want to reap the full benefits. If you have an application that works fine, there is no need to change. Blocking code is easier to write, and you have a maximum choice of libraries, since historically most are blocking. Non-blocking functional code and declarative programming has a learning curve. And remember, in microservices architecture you can have a mix of both and use the best choice for the problem you are trying to solve.